Okay guys, hello. This is chapter 6.1, talking about polygons. Okay, let's talk a little bit about the vocabulary over here on the side. You got a polygon as a plane figure formed by three or more segments. A segment would be like, just a straight line. It's got to be straight, okay? And you got to have at least three of them, okay, in order to make a segment. So for example, you can't have a if I kind of move over here to the side, you cannot have a polygon that looks like this. That's two segments. It's open in this area here, okay? It's got to be closed, which we'll talk about here in a little bit. Okay, so it's made by three or more segments. A side, which again is just a segment, it's just a piece of it. It connects two vertices. Now, a vertice, or a vertex point, is an end point of the figure. So that would be right here, like this one has four vertices, or four end points, okay? And it's made just by the two sides. Two sides come together, they make a vertice. Now, diagonal connects two non-consecutive vertices, meaning, we'll come over here to the side again. If I just have this square, you guys know what a diagonal is, but it's connecting two non-consecutive. Consecutive would mean they come right after another. Well, see here we're skipping this one and going straight to that one, going across. So you're skipping a corner basically, or an end point. All right. So, and then we have the quadrilateral interior angles theorem, which basically says all the measures of a quadrilateral, four-sided figure, have to equal 360. Just like all triangles have to equal 180, here, all quadrilaterals need to equal 360 degrees. So let's take a look at example 1. And they're just wanting yes or no. Are these polygons, are they a polygon? Okay. And number 1, you can see, okay, does it meet the criteria, basically? You got 3 checkpoints here. All right. Checkpoint 1 is, does it have 3 or more segments? Okay. That's the first one, and they got to be closed. They got to make with straight sides. So check 2, are they made with straight sides? Okay. And do they have endpoints? That could be kind of check 3, I guess. I don't necessarily think. I mean, they have to have endpoints if the sides come together. So looking at A, does it meet all 3? Does it have 3 or more sides? Yes. It's got 4 sides. Are all the sides straight? Yes. Is it a closed figure? Yes. So we would say yes to letter A. Letter B, does it have more than 3 sides? It has 3 sides, but the problem is with B is this curve right here. Okay, that is not a side. The sides have to be straight. So this one would be a no. Letter C, again, this is going to be a no, and how come? Right here. A polygon cannot be left open, all right? So there's a no. And D, what do you think about D? If you're thinking yes, you're right. 3 or more sides? Obviously, yeah, there's 3 or more sides. Okay, and is it a closed figure? Like there's no openings? That's correct. There's vertices, there's vertex points where all the sides come together. So this one would be a yes. Not too tough. Okay, example 2, we need to decide whether the figure is a polygon. If so, tell us what type of shape. Okay. Now, off to the side here, let's kind of write in a few important things. Okay, so types of triangles that we know. A 3-sided figure, you should already know that's a triangle. These are elementary type things, but just so you have them here. 4-sided figure is called a quadrilateral. I'm just going to abbreviate quadrilateral. 5-sided figure, pentagon. Six-sided figure is called a hexagon. Seven-sided figure is called a heptagon. And an eight-sided figure, like a stop sign, octagon. Okay? So that'll be helpful whenever we're answering A, B, C, and D here. So letter A, how many sides are there? Well, just count 1, 2, 3, 4. Four-sided figure. You should write quadrilateral. Okay? Letter B. First, again, is this a quadrilateral? Does it have 3 or more sides? I've got 1, 2 straight sides, but then we've got these arcs. That's not going to cut it. That's only 2 sides. So this is no, not a quadrilateral in general. I guess over here we should have said yes first. Quadrilateral. Okay, so B's not a polygon. C, is it a polygon? Does it meet all the criteria from that we did up in letter A? 1, 2, 3, 4. Okay, 5 sides. They're all closed. They're all straight. They come to a vertex point, so we would say yes. And then it's a 5-sided figure, so therefore is a pentagon. And D looks a little different here. Let's check it out. 3 or more sides? Yeah, 1, 2, 3, 4, 5, 6 sides. Are they all closed? Do they all come to a point? Yeah, they do. So that would be a yes. It's a polygon. How many sides was it? I believe it was 6, right? Which would mean it's a hexagon. Okay, pretty simple. Last example. I want to figure out what the measure of angle S is, okay? That's this angle right here. We want to know how many degrees it is. Now, if you recall from that theorem, it just said that if it's quadrilateral, all the angles have to add up to 360. Well, this is a quadrilateral. 1, 2, 3, 4-sided figure. So basically, to write an equation, we could sit here and say, okay, angle S plus 70 plus 80 plus 70 equals 360. So you'd want to add these 3 like terms together. Okay, so we're going to have angle S plus 220 equals 360. Then we subtract a 220. Whoops, 220. That zeroes out. So the measure of angle S is going to equal 140 degrees. That's all you got to do. It's got to be a quadrilateral. It's got to be a 4-sided figure. Okay? And they got a total 180 degrees. Just set up an equation like I did right here. All right? And solve for the missing angle. You could give it a letter. You could call it X or anything like that. All right? That's it for Chapter 1. Or Chapter 1. Section 1, Chapter 6. Have a good day.